Now that you've done moon phases, and you really trained this scene from Earth, seen from space, why it's happening, you can talk about eclipses fairly quickly, especially with that last detailed drawing of moon phases. Okay, so what's happening? Well, we were drawing North Pole, so that again is a top view, and we were showing moon orbiting. But we were neglecting the shadow of Earth and the shadow of moon. I mean, anything in the light has a lit side, a not lit side, a terminator, and a shadow, right? And the side you see is the side facing you. If you have that, you're in good shape. Okay, so here, for example, you'd say, well, doesn't Earth cast a shadow onto moon? Or if moon were over here, wouldn't moon cast a shadow onto Earth? And the answer is no, not always. And the reason is, if I draw now a side view of the orbit of moon, I can see that moon is sometimes higher than Earth's shadow, and sometimes it's lower. And that varies, and so that's a cycle you can study if you want, but sometimes it's higher, sometimes it's lower here. So it could be high here and low here, it could be high here, it could be low here, it could be high here, it could be low here. It varies, okay? So there is a pattern, but just understand that that tilt of Earth's orbit, so if sun was in line here, moon is not exactly on the same plane. It's about a 5 degree, which is about a thumb at arm's length, tilt from that orbit. And that means, if you take a look, sun being way out there, Earth here, day side, night side, spinning around, right? So if I have moon, let's put it over here, then moon would cast a shadow right now onto Earth. But if moon was up here, moon shadow would be above Earth, or moon shadow would be below Earth. What phase would Earthlings see when they text it to you? What phase do they see? They don't see this lit side, they see the not lit side, or a new moon, right? So on a new moon, sometimes moon will block sun. And we only see that if moon shadow is not above nor below, but actually hits Earth. Would you see it if you were having, when that happened, if you were having nighttime or daytime? You couldn't see it over here, right? You'd have to be over here. And not only that, moon's shadow would be fairly small. Think 100 miles. So it's fairly small. You've got to pass through moon, that small moon shadow, to be able to experience that eclipse. What kind of eclipse? A solar eclipse. New moon, seen at day, but you've got to pass through there. And not every new moon, because sometimes new moon's shadow will be above or below Earth. 1 week, 2 weeks later, now seen from Earth, you see the all lit side, a full moon. It might be above Earth's shadow or below, but if it goes through Earth's shadow, the light is blocked from moon. We call that a lunar eclipse. You would see it on the day side of Earth. In fact, everybody, since everyone on Earth sees the same phase, everybody would see it that's having nighttime and a clear sky. So there you have it. Let's take a look over here at the board and finish this quick little topic off. But you should be able to visualize this at this point and explain this to your friend, especially since you have drawn such a detailed picture for moon phases. Remember, again, top view, North Pole there, so you see the ball. We're spinning around about 24 hours. We know there's 2 meetings per day, but not over worrying about that. This is Earth. Moon, that's really about the size of Mars compared to Earth. Moon is maybe half that diameter. We're not worrying about that. We do know that sunlight hits this side. So draw the terminator, shade the dark side. Right? Not worrying about moon spinning until the next section. The side facing us would be this. Okay. This would, seen from Earth, moon would be blocking sun, so this is a solar eclipse. This happens only if moon shadow hits Earth, or if moon shadow is not above or below Earth. But it will always be a new moon, right? We see this. It is seen, well, you have to be on this side. So seen at day, this more rare or common to see. It's pretty rare because not only do you have to have daytime, all these folks couldn't see it when it's happening. And some might be blocked 2 to 4 minutes. But you've got to go through that small shadow that moon casts onto Earth. And so, more rare, and you can say why. Now we come over here, and we say, okay, Earth is spinning, moon is orbiting, a few days later, about 1 week, first quarter, right? Waxing, crescent, first quarter, waxing, give us full, sunlight over here. Now we're looking at Earth's shadow. Earth casts a shadow behind it. This phase, obviously the side facing Earth is all lit, so we call that the near side. Or if you like, my little guy there, near side, near side. As moon orbits, the side facing sun is always lit. The side facing us is what we see. This is, of course, a lunar eclipse. It's a full moon. It happens only if moon passes through, not above and not below, Earth's shadow. It's seen, well, if you're seen from Earth, you're not going to see it if you're having daytime, but if you have nighttime, seen at night, it's more rare, more common. It's more common to see because everybody on the night side, as long as you're having nighttime, these folks couldn't see it, but, you know, not bad. Then you've got your lunar eclipse. That's what we see from space. And from Earth, I'll let you take a look on the internet at some images of people that, pictures that have been taken of the gorgeous orange moon, really, as it goes into a lunar eclipse, and images of a solar eclipse. So you do that. And I was going to mention one other thing so in antiquity, of course, people freaked out. Everything was bad luck. They didn't know what was going on. Who's pulling our chains? What's going on around here? Oh no, our sun god is going away, Inti Ra, going away, Helios. And that must mean we did something bad. But now we know why. And that's okay that people thought that because they didn't know. But now we get to leave the planet. All right, cheers.